All right, guys. So in this video, I'm just going to be talking and showing you a couple of ways that you can manipulate the PHET on reaction rates. So big thing about this is on the kinetic and molecular theory. So if you haven't watched those videos yet, go back and take a look at them. And this PHET is actually, it does a really good job explaining a lot of key things that you should be able to understand after you play around with it. So basically what you're going to do, if you have a tough time opening it, you can just watch my explanation. I think you'll get the idea of what we can change. So we're just going to look at single equations first. So let's take a quick look here. So you can do all kinds of interesting things here. You have a reaction. So these are two reactants, and then it tells you your equation over here. So these are your reactants. These would be your products, right? So it's going to be a single displacement reaction. So you're trying to get these two products. Now, the main thing that you want to at least be able to understand is remember that this is the activation energy and this is going to be in your products, right? So just kind of take a look here. If I pull on the slingshot here and I just release it, right? You can kind of see what's happening here. We haven't gotten huge into equilibrium yet, but remember your product can reform your reactants. And in this case, it's just going on one straight plane. So a reactant hits it, and then all of a sudden it just hit it in some orientation. And now I can let this sit here for a while. Now notice that when that hit, one of the key things that you need to know about the kinetic molecular theory is the substrates. Okay, the two reactants have to actually hit in the correct orientation. Otherwise, your reaction is not going to proceed. So you have to be careful with how that all plays out. Now, in terms of this, I'm going to go ahead and reset this. Again, if I switch this out too, and I want to show you guys a couple of other things. What if I just barely pull on the slingshot? In this case, it hit in the correct orientation, but notice that I'm not even getting my product at all. So I'm not quite getting over this activation energy barrier. So that's something that you also have to understand. So these things have to hit in the correct orientation, and they also have to collide with enough force to actually get your product. So that's something that I think is important for you guys to be able to understand. So let's play around with a couple things here as well. I'm going to go ahead and switch it to where, notice the difference in the size of these. So C is quite a bit smaller than my other molecule A. So if I pulled this, look how much faster that this silver molecule C moves than this one in the yellow. So notice that it definitely changes you're transferring the energy. That's a big component of what you should be looking at here. So in terms of variables, let's go back to the actual handout. So what can we change? We can change quite a few things. Let me go through and emphasize a few more things. So let's kind of do an angled shot, and we kind of have already talked about this. If I pulled it, and let's say I provided it with enough energy, see if I can get it to hit. Notice that I had enough movement for them to actually get over that activation barrier, but they aren't actually colliding at the correct spot. So that's something that is important as well. So again, you can play around with all these, but if you look through here, if I change the reactants, notice that the total energy of the initial reactants and the products is going to be the same. So you can kind of let this thing play out. A lot of this is going to be pretty self-explanatory, but the big variables that you're able to change is the actual energy provided initially. And that's important for you guys to be able to understand. So other than that one, actually this one was pretty interesting too, that this one, and you look at the graph, this is a single collision, but notice that you have a lot of energy in the reactants. So, and there's no essentially activation energy barrier to get over. So in this one, I think it's pretty cool. And I've actually honestly never sat and let this play out until just now. They just barely have to collide and then you get your product. So that's something that it has relatively no activation energy. So pay attention to the graph, and that kind of tells you. So in this one, right? So if I kind of did it, let's just say halfway, I'm not even going to get my product because it takes a lot of reactants to get over that. So other than that, yeah, this one should be pretty equidistant on reactant products. So pay attention to that activation energy. It's pretty important. So yeah, that's kind of how you would explore the single, what variables we can change, and you can kind of fill that out and replay it if you want. But The second thing you want to at least take a second and look through is we now need to look at temperature, concentration, active energy, and the rate. So if you go and play around now with this, we can do some cool stuff. So let's look at mini collisions now. Let's say if I have, I'll put 20 of A and I'll add 20 of B. And I'm going to go and let those things play out. And let's go ahead and look at a chart, right? So if I let this play out, A and B and C, they're hitting each other. But the big thing about this one is that I get one or two small amounts of product, but it's not happening as quickly as I would like. So let's play around with the variables that we can. So what would happen if I raise the temperature? So these molecules are moving faster and faster and faster. Now, in terms of this, they are colliding. I have reached, I don't want to quite call it equilibrium, but I'm seeing kind of a products and then my reactants reforming, kind of going back and forth. So in terms of that, let's do a different reaction, right? So let's do A with B and C. Again, relatively no activation energy on this chart. So let's just do 10, and we'll do 10 of my B and C. And again, this is going to happen pretty seamlessly. And again, because of that activation energy, it all matters. So I'm going to go ahead and reset all of this. Let's go back to our initial equation. Let's look at the bar graph. Let's see if the amount of our reactants matter. So what if I do 100 and 100? Well, again, I mean, it's making the computer even lag. But again, there's a relative high amount of pressure. I know it's not a variable in this case, but you have a high concentration. And again, I'm not seeing my products quite, I mean, the same applications are gonna apply here, where if I increase the temperature, it would actually start to get my product changing, getting more products as well. So moving forward into this, increase temperature, decrease temperature, increase the concentration and decrease the concentration of the reactants. We can kind of do that as well, percentage wise. So when you think about concentration, let's take a look here. What if I just had 20 and 20 again, right? That's something that I think is pretty simple for you guys to see right here, that I could sit here for a long time. I might get one or two of my products, and just think of it in terms of percentages, right? So if I had 20 and 20, and I don't change the temperature at all, I'm not really getting a high amount of my product. If I change this, and I got one, but that's not a very high percentage. So let's go back to the example of 100 and 100. So 100 and 100. Oops, I gotta change this real quick. So I'm just gonna reset all this. So if I do a 100 and 100, okay, just look how fast not only my amount of product that I'm making, but the percentage of my product that I'm actually making. So right away, almost right off the bat, at least I'm getting like 10%, almost to 20% of my product. Now, if I raise the temperature again, you're going to see even more product. So that's something that I think you guys should all be able to see pretty equally. So I'm going to go and reset this and see if there's any other variables that we can play around with in this case. And decrease the concentration of the reactants, increase the concentration. So again, yeah, you can already play around with that, and you should have seen that. What if I just had 1 and 1, and I let this play out? This is like that old DVD screen where you were just waiting. I mean, there might be a chance where these things actually might collide with enough energy and actually get my product, but it is just completely due to chance. Now, even if I speed up, or I should say increase the temperature, increasing the kinetic energy, I got close there. So let's see, yeah, have fun with this. If you get really bored and you just want to see how long it takes to get your product, you might be able to. But yeah, so decrease the concentration, you're going to decrease the amount of product just because it's going to be a lot tougher for the products to actually get formed. So understanding that, I think a lot of this should kind of help explain this. So in terms of reaction rates, let's kind of just take a look here, rate experiments. So let's start with 10, 10, 10. Actually, for our we're gonna do it with our 0, 0. So 10 and 10. And let's go ahead and let this begin. So this is basically kind of showing you what we've already been going over. So you can let this play out, and if we started a timer, you're not necessarily seeing any bonds breaking and forming again. So again, there's all kinds of stuff that we can look at. So if we just did this experiment with a really low activation energy, if we began this, look how fast you're going to be getting your product as soon as they touch. It has a really, really literally no activation barriers. As soon as they collide, they're going to be forming their product, as long as they hit in the correct orientation. So it just depends on the reaction. You got to really look at a couple of variables, but this should at least kind of give you an overview of everything that you should be able to see in the PHET. So other than that, I hope that this video helped you and at least get you guys able to answer a couple of questions on this. So we'll see you guys in the next video.